Welcome to the NCRS Insider, bringing you into the NCRS world with your host, Steve Thazier.
Hello everyone. We're going to take a break from our Project LT1. I realize that not everyone is restoring an early C3 Corvette. So we're starting a series on common C3 Corvette problems. We will intermix these in with our LT1 episodes at the beginning of each month. So here we go. We will start off with the frame that was used from 1963 through 1982. So this will not only cover C3s, but it will include C2s as well. There were subtle differences over the years, but the general design remained the same. A problem area with this particular frame was the low front cross member. The center dipped down to roughly 7.5 inches from the ground under the front of the engine block. Because it is so low, it is prone to damage from hitting ground objects. It is also quite common to get damage from using a jack in this area. The steel in this area is just not strong enough to take the pressure from the jack below and the weight of the front of the car, especially with the engine directly above. So the steel just crushes upward, leaving an ugly looking frame in its place. Now most people might think that the only fix to this is replacing the steel in this area. And that can certainly be done. Corvette Central makes a replacement steel piece that spans the entire bottom side of the cross member, which includes the bottom side of the shock tunnel. However, this is no easy task. The actual removal of the steel plate requires all the plug welds to be drilled out and the plate pried off without damaging the remainder of the frame. A gentle hand and a lot of patience is required to perform this task successfully. I'm sure a professional can handle this task with success, but I would not suggest the average Joe trying to restore his car attempt this. You might just end up in a worse place than you started. The second option is applying a plate to the bottom side of the existing plate with 4 bolts. However, if you are doing an NCRS restoration, this is certainly straying from the original fit and finish that left the factory. You would be better off leaving the damage as is. Third option is just using some type of body filler to build this area up to the original plane. You should be able to get this to look good, but will an NCRS judge pick that up? Maybe yes, maybe no. So that leads us to the final solution that I chose to do. There's actually a tool made by Corvette Central that is used to push the steel back into its place. I was a little skeptical at the beginning, but after researching a bit, I thought I would give it a try. The tool is not cheap. With shipping and tax, it comes to a total of $221.22. A fair amount of money, but it does the job pretty well. The kit comes with a number of individual pieces. There is a curved straightening backing plate matching the curvature of the steel, a straightening bracket, a large bolt to compress everything together, 4 large washers, a series of shims, and instructions on how it is to be used. Here is a simple graphic to convey how this works. This is a section through the frame with a bit of exaggeration of the curvature. The black lines are the profile of the steel box frame. You can see the crushed portion at the bottom. There is a hole in the center of this section. The straightening plate is placed behind the crushed section. The bracket is then placed on the opposite side of the steel, and a bolt is inserted through the center hole in the frame into the plate. As the bolt is turned, the plate is pushed downward, straightening the frame. In concept, it seems quite simple. After studying the pieces and the parts and reading the directions, it was time to begin the process. The first step is to get the straightening plate into the frame behind the damaged portion. This is accomplished by going through the shock tunnel and up to the center of the frame. If attempting this with the front end on the car, you will need to remove the entire wheel and a suspension assembly on one side to get to the shock tunnel. Getting the plate into place does require smaller hands and arms since it is a tight squeeze. I would suggest wearing a long sleeve shirt since your arm is going to rub quite hard against the corner of the steel at the shock tunnel, and you will be doing this many times. Since I had the body off the frame, I did the work with the frame upside down, which seems to be the easiest way. With the plate being held in place against the lower portion of the frame, the bolt needs to run through the center hole in the frame and screw into the backing plate. Sounds easy enough. Here was problem number 1. The plate would not fit inside the frame correctly to align with the bolt hole, so the bolt could not be screwed in. It was not off more than about 1/8 of an inch, but after numerous attempts, it was not going to work. Without being able to see within the frame, it was hard to tell the specifics of the problem, but I started grinding the edges of the backing plate since the directions do say that may need to be done. And then I did some more grinding, and then some more and some more. After about 5 or 6 attempts, this was not working. I started studying the problem a bit more, looking at the size of the plate and comparing it to the frame and imagining how it was sitting inside that frame. I realized that the bottom of the frame was crushed so much that the plate would not fit into the correct location to align with the bolt. Here is another graphic to convey the problem. We are now cutting the section in the opposite direction from our first graphic. At the rear of the box frame, towards the center section, there is a much narrower section to deal with. Because the crushed section was so bad, the plate would not fit in this area to allow the alignment with the hole for the bolt. We needed to get a little more serious with modifying the plate to get it to fit. Now we were cutting metal and not just grinding. With some careful measurements being taken, the precise amount of steel to be removed was determined, and finally we were able to get the plate to fit correctly. With the backing plate in its correct place, the bolt could now be screwed into it. We used 3 of the washers at the bolt above the straightening plate, which seemed to work fine. A 1-inch socket and ratchet were used to tighten the bolt. Before the steel moved much, the ratchet turning got a bit difficult. An additional pipe for more leverage might be needed since a considerable amount of force is required. After a few more turns, the steel started moving in the correct direction. After removal of everything, things appeared better, but there were still a number of bumps and depressions to deal with. Using a straight edge is a good way to tell where the ups and downs are. That is where the shims come into play. The kit comes with a number of different size shims. Taping the shims to the backing plate is a must to get them to stay in the desired location. Depending on where you need to get more dips out will depend on the shims that are required. To get the small bumps and depressions out, I needed much smaller shim pieces. I used some 1/8 inch scrap steel. After lining up the shims with the depressions, the shims were taped to the plate to keep them in place. The plate goes back inside the frame and the process repeated again. After many more shim placements, inserting the backing plate, and ratcheting down the plate, the steel was looking pretty good. For some minor humps, a hammer was used to level those out. After applying paint, it was not perfectly smooth, but a tremendous improvement over what we started with. So that wraps up this video. I hope this helps with fixing your damaged frame front cross member. As always, please subscribe if you enjoyed this video. We'll see you next time.